form, so we need to subtract 2x, subtract 2x. We now have 0 plus y. Y equals 0 minus 2x, negative 2x. We have a m of negative 2 and a b of 0. So that means that my constant of variation is really negative 2. Because my y-intercept is 0, this is, oops, I missed an s. This is direct variation. You try problems 3 and 4. Alright, so hopefully you did problems 3 and 4 and you didn't have too much trouble changing it to slope-intercept form. And hopefully you noticed that in both 3 and 4, the b value, the y-intercept, becomes 0. And that these are both direct variation, which means that our slope we can call our constant of variation if we were asked to identify it. So, let's go to the next part. What if they ask us to graph a direct variation equation? First, they told us that we have it. Graph the direct variation 2x. Find the x value that matches up with the y value, negative 2. Show where this point is on the line. Alright, here we go. Well, I think the first thing that I would do is use my slope-intercept form to graph this line. I don't think I'm really going to create a table if I don't have to. So, my k, because this is direct variation, or my m, I don't care which letter you use in this section, is equal to 2. Remember, that tells me that I need to rise 2 every time I move right 1. And my starting point, because b is equal to 0, that's my starting point. So I start at 0. And I rise 2, right 1, rise 2. Notice we haven't done anything different. Just graphing lines here. Putting in all the possible points that I can. And connecting the dots. And you're using a straight edge and not making wiggle worms like I make. And now that I've got all these points sketched in, I should be able to read my graph as opposed to having to plug anything in. So when I find the x value that matches up with the y value, negative 2. So y value of negative 2, the x value would be 1. So the answer to part A here. When x is negative 1, the y is negative 2. And to show where it is on the graph, I've already plotted it, and I just need to label it. Negative 1, negative 2. Now here's the next type of question that is definitely a likely question. Graph the, oops, let me put this back on the screen. The graph of a direct variation equation is shown to pass through the point negative 1, positive 2. Negative 1, positive 2. So now we officially know 2 points on this graph. Because they said direct variation, we know that the second point, unspoken, is that y-intercept of 0, 0. Write the direct variation equation. Remember, that means they want you to give y equals kx. You got to find k first. Remember, to find k, we can apply the slope formula, but since our second point is 0, 0, we can cheat a little bit. Change in y over change in x. Change in y over change in x. So we end up with a k value of negative 2. So our equation is just y equals negative 2x. Every y value is going to be negative 2 times the x value. Negative 2 times negative 1 is definitely positive 2. My equation works just fine. Now the second part, part B, is to find the value of y when x is 30. So what would y be if I plugged in a negative 30 for, positive 30 for x? Negative 2 times positive 30 would tell me that that y value is negative 60. Nothing fancy. That's 4.6.